Hi, Dr. Caney again. One of the key concepts in Chapter 2 is the idea that freely falling objects near the Earth's surface all accelerate uniformly at the same rate, 9.8 meters per second squared, regardless of shape, composition, heavy, light, and so on. To qualify as freely falling just means that gravity has to be the only thing acting, no other outside influences. The trickiest one to consider is actually air resistance. To really see it in action, you have to drop things in a vacuum. I'm going to drop a couple objects to kind of test this, and I'm not going to do it in a vacuum. But I've chosen two things that are fairly streamlined and fairly similar in size, and we're not going to drop them very far. These size objects, dropping just a few feet, shouldn't experience a whole lot of air resistance. It shouldn't make much difference. I did, however, purposely choose two things that are very, very different in weight. Very, very light ping pong ball, and then this is a steel socket. In fact, there's about roughly 100 to 1 times difference between these two. So if that matters, if heavier things do tend to fall faster, there ought to be a pretty big difference. If this fell 100 times or anywhere close to 100 times faster than this, that's something that you ought to be able to see. One thing about a science class is that we don't have to just take the book's word for it always. We can actually test things. So, got my two objects. I'm going to just drop them to the floor, release them from rest. I've got some padding down there so I don't chip the flooring, but and I'm going to just release them by hand here, so you can't get too picky on me. But the count of 3, kind of watch them as they progress down toward the floor. 1, 2, 3. Look pretty close to neck and neck here. Certainly not a big difference. Do it one more time. 1, 2, 3. Now, air resistance does complicate things. If I tried the same demo with the ping pong ball and a piece of paper, you expect a different result. The paper's not just going to fall straight down. You know that the paper catches the air right away. Air resistance is a very big deal for the paper just within the first few inches. But you can see that it really is just the air. If you could get rid of the air resistance factor, things start to become more equal. If I just make the paper a little bit more streamlined. Maybe a little closer. Make it more streamlined yet. Okay. That's getting closer. And if I can really take away the differences of air resistance and make the paper much more compact, we're back to pretty much a neck and neck drop.